My name is Maurice Svay. I'm actually a UX designer working at Sketchfab. Sketchfab is a platform for publishing 3D models, which had nothing to do with what we're going to talk about tonight. I'm going to talk about the Sparkcore we just saw in the previous talk. So the Sparkcore is an interesting microcontroller I just got a few days ago. It was a Kickstarter project. As you can see, it was really successful. They raised $500,000, and they think they started last spring. So the Sparkcore is open source. All the files are available on GitHub. You can find the software and the Eagle files, which is nice. It's Arduino compatible, which means that you can program your firmware with the same language than for Arduino. It comes with a cloud IDE and API, and we'll see later what it means. It also comes with mobile apps for iOS and Android. They've built a series of shields for supporting Arduino shields for battery and others I don't remember. And it only costs $39, which is pretty cheap for what it does. So what it does, it has a Cortex M3 microcontroller that runs at 72 megahertz and has 128 kilobits of flash. It has 8 digital IOs and 8 analog PWM. It has pins for serial SPI, I2C, and JTAG. All the pins are 3.3 volts, which is important because it can be different from what you can know in the Arduino world. It also has 2 megabytes of external flash. And more importantly, it has Wi-Fi with a Texas Instruments CC3000 chip. This chip is really interesting because it's cheap and it's easily configurable with a mobile app. So this is the Sparkcore. Underneath you will have the main chip, the Cortex M3. Here you have the 2 megabytes chip, 2 megabytes, sorry, chip for storage. It has a power regulator. It's fairly small. It's about 2 centimeters by 3.5. On the top, you can see the micro USB port for scale. On top, you have the CC3000 Wi-Fi module. And at the bottom, there is the ceramic antenna. So for the ports, you get all the 3.3 volts, plus a filtered one, serial pins, SPI, I2C, JTAG. Now I'm going to show you what it looks like. So I have it here. It comes with a nice breadboard, and I've plugged a push button and an LED. Show you here. Yeah. So the Sparkcore comes with an iOS app that looks like this. They call it Tinker. So basically, it allows you to turn on and off the pins. So right here, I have a LED connected on D0. I can turn it high. I'm not sure if you can see it, but basically the LED turns on. You can turn it off. It also has a built-in LED. It can here that turns blue when high and low. So the interesting thing that it works with Wi-Fi. So basically, this thing is connected to a server from Sparkcore, and my app is connected to the API. So it's a nice way to try it out. But more interesting.
So is it a local demo, or does it go to the cloud? And
It goes to the cloud, to Spark Cloud. So what I'm going to try to do now is try to try another firmware. So here I have in my browser the Cloud IDE, in which I can type code in the same language than Arduino. So this is a very simple program, but interesting one, because this program is going to expose the variable to the cloud. So basically, I'm going to push a button and see if it's high or low. And the first line, where you can see spark.variable, basically this line exposes the button variable through a REST API. So what I'm going to do is to send this program through the cloud and to my microcontroller. You can see that it's updating by flashing purple. It takes some time.
Do you know what the consumption? What is the consumption of the?
From what I remember, it's about 100 to 3,000, 300 milliamp when communicating, but they have sleep mode where it's almost nothing, like a few microamp.
Can you wake up from sleep mode through Wi-Fi?
Maybe with an interrupt, but I'm not sure. I just got it a few days ago, so the firmware has been updated, and here I have the API that returns JSON. If I refresh, it tells me that the device is connected, and that the button reads 0. So basically it's not pushed. If I push on the button and I refresh, it says that it's 1. So it can see that I'm pushing the button. If I release, refresh, it says 0. So basically it's a really easy way to get the status of this device through the cloud. So for now, when they say that they are Arduino compatible, you have to remember that it's not an Avia chip, it's a Cortex M3. So basically what they did, they ported all the API from Arduino. So for now they have the most of the usual things like I/O, serial, SPI, I2C. But also they added TCP, TCP server and client, UDP. They ported the server library. They also have time interrupts and math. And the nice thing is that the board has a RGB LED that you can control with a special library. And the most important thing is that they have the cloud API built in the library. So far it looks pretty good, but unfortunately there are some drawbacks. As you can see, you have to program with the Cloud IDE, so it means that you cannot use the usual libraries that you can find for Arduino. You cannot include files. For now, there are no desktop IDE. They say that there is a command line tool coming that would allow programming with a USB cable. The documentation is still lacking. There are a lot of doc missing. As you can see, the upload to with Wi-Fi is quite slow. My program was only a few lines of code, and it took a few seconds to upload. And if you really want to upload your firmware with a USB cable, it's really pain in the ass because you have to go through a GFU mode and a whole C++ toolchain, which is much harder than the Arduino IDE. So that's it. If you're interested, you can see it after the demo.
When you program in the cloud, is it sending a binary over Wi-Fi or?
So basically what they do, you program in their IDE, which is on their servers. They have a farm of compilers, from what I understand, that build a binary firmware and then send the firmware through the cloud to the board.
Is there a cellular capability for that?
I don't think so. They don't have any shield for that. Only works for Wi-Fi.
And how come this is $32? I guess it's quite cheap, but it's not the M3 that costs so much. So
I don't really know how they.
Is it just Wi-Fi that is?
The Wi-Fi chip is supposed to be pretty cheap, and the interesting part of this chip is that you can configure it with an app. Adafruit has the same chip as a breakout board, and from what I remember, it was approximately $30 only for the Wi-Fi chip.
Because if someone wants to build a Wi-Fi connected device, that sets a minimum price quite high.
Yeah.
Because that means any Wi-Fi device is going to be like $60 retail.
This kind of device is level for production, so
Yeah,
prototype.
This is for prototyping, obviously.
So what you're buying is access to the cloud.
Yeah, the interesting thing is the software part. It comes with a cloud, so you don't have to build all the infrastructure for connecting to your device. They also handle the security for you. From what I read, all the communication is encrypted, so that's a good thing, I guess.
That's what they tell you.
They tell you that they use AES encryption and so on.
NSA encryption.
Yeah, they couldn't say anything.
Yeah.
Okay. Any more questions? Okay, thank you, Maurice.